We are going to be learning to understand composite functions today. So just quickly, a composite function is a function that is created when the output of one function is used as the input of another function. For an example, we've got two functions here. We've got f of x is equal to 3x plus 2, and we've also got g of x is equal to x squared. So to start off with, we have 3 going into our f function, f machine. That is an x value, also known as an input. An x value we talk about as the domain of the f. It spits out the 11. And 11 is the output, the range of the f function. We've got that 11 by going 3 times 3 plus 2. This output of the F machine turns into the input of the G machine. That means the range of F is the domain of G, the input. And input then turns into the output, which is the range of G, and which is 141. So our new composite function of g f of x is h of x is equal to 3x plus 2 in brackets squared. All we've done is we've grouped 3x plus 2 and substituted in for the x value. Another diagram to help represent this is we start off with the domain f, which is our x value. That turns into the range of f, also known as f of x, and we call that now the domain of g, because that is what our input for our g function. Then that turns into our range of g, which is our composite function of g f of x. So to start with, we've got three functions here. We've got f of x, g of x, and h of x. The first question is saying g h of x. So we've got a composite function. So we're looking at h of x and g of x. So let's write those down. G of x is 2x to the power of 3 minus 5. H of x is equal to x plus 4. The second part is we need to group our h of x, and which is x plus 4, and put it inside the x or g. So that turns into 2x plus 4 to the power of 3 minus 5. Our next composite function is h f of x. So f of x is square root 3 minus x, and h of x is x plus 4. So again, we've got f of x here first, so that is going to be grabbed and taken into our h function. So that means we've got the square root of 3 minus x has been substituted in, and it turns into square root 3 minus x plus 4. Another way to think about it is if the function exists, then our range of our first function will be a subset for the domain of the g function. If it is not, then then the composite function won't exist unless we put restrictions on our function. So to start off with, when we've got f of x is equal to square root 4 minus x, and g of x is equal to x minus 1. The first thing we need to do is work out what is the domain and what is the range of both functions. So let's look at the domain first. So with a f of x function, we know that the square root can't be a negative, which means the biggest number x can be is 4. So it'll be negative infinity all the way through to 4. Now it can be equal to 4, so I'm just going to change what I've got here. It should be a square bracket. So look at g of x. We know g of x is a linear, which means it's all real numbers. If we move on now to the range. So the range is we of f of x. Again, the square root part, it has to be 0 or positive. So we know our range will be equal to 0 or to infinity. And our linear g of x, the range will always be all real numbers. Let's go into our machine that we looked at before. We need to look at our range of g, which is R, and we need to look at our domain of f. At the moment, the range of G is not a subset of the domain of f. That means every, every single number can't go into the function. So therefore, it is not a subset, and therefore, currently, in this form, it is not defined. This is where we need to restrict the domain. To do that, we need to first look at what is in common using the table. So what is in common between both of them? They're both in red, so we can easily see it. And it's really good looking at the negative affinity to 4 for the domain of f of x. But this is the domain for f of x. We need to use them as our range and put it back into our machine and go all the way up to find out what was our original input into the g function. So to do that, we are going to grab the equation g of x is equal to x minus 1. I'm going to use that for, and I'm going to plug it into my equation to find the maximum for my domain. So I have 4 equals x minus 1, and that gives me x is equal to 5. Now I've got my new domain. I know my x elements are going to be negative, is negative infinity all the way through to 5. The next part I need to do is I need to look at what is my function. That means I'm going to start substituting. So I've grabbed my g of x and I'm plugging it into my f of x formula, my f of x equation, and that gives me my h of x is equal to square root for take away x, take away 1. Be mindful when we expand this will be a take away x, and this will be take away negative 1, which will be plus 1, and give me 4 plus 1 is 5. So the final answer should be h of x is equal to square root 5 minus x, where x elements are between negative infinity and 5. That is my restriction. Let's have another. We have here the function f and g are defined by f for all real numbers, and is described by real numbers. F of x is equal to x squared plus 1, and g is the domain of negative 2 to infinity for all real numbers, and g of x is equal to square root x plus 2. We're wanting to show that f g of x exists and find the rule for f g of x, stating its domain and range. So we start off with for fx is a parabola. Parabola x values are all real numbers. And then for my real numbers, for my domain of g of x, I know I can only have a square root that is 0 or positive. So that means it will be equal to negative 2 to infinity. Likewise with range for a parabola, range starts with your turning point, and my turning point is at 1, and it's a minimum, so it will be 1 to infinity. Whereas if I look at g of x, the square root is a positive on the outside, which also means that I'm dealing with positive numbers, so it'll be 0 equal to 0 to infinity. Next thing we're going to be looking at is we're going to go back to our machine. I like using this machine because it makes it a lot easier to visualize. So this machine just tells me that we're looking at our range of G, and is it a subset of our domain of F? So our range of G is 0 to infinity, and that is our subset of our domain of F. Because of this, that just means we're going using this range and going back. What did I put in? We put in -2 to infinity. So that will be my domain of my new function. But we do need to determine our new function. So we're going to do the same thing. We're going to grab both of our functions. We're going to look at this part here. It says g of x in here. So we're going to grab that and put it into our f of x function. So that means we've grabbed square root x plus 2, and we're throwing it into where we see x. So that gives us the square root of x plus 2 to the power of 2 plus 1. The domain, as we've already said, is -2 to infinity, and we put that in to work out what our range will be, but we can also see our range here will be starting at 1 to infinity. Last question that we will be doing today, it says if f um, has a domain of equal to 1 to infinity and is described by all real numbers, f of x is equal to negative square root x plus k, and g is negative infinity all the way through to 2. For all real numbers, g of x is equal to x squared plus k, where k is a positive constant. Calculate the values for k such that both g of x and g f of x are defined. The first thing I just put into my table is what we've already been told. So we've already been told the domain for both of our functions. I've just grabbed that from our function notation and placed it in. The next thing we need to look at is our range. What would our range be? So let's look at g of x first for our range. So we know it is a parabola, but it says k is a positive constant. So that we know without k, it would have a turning point at 0. So with k, k is going to be our smallest amount, and that's going to keep increasing. That's why I put down as k to infinity. Then I look at f of x. So normally square root x would start at 0, negative is going to go down the -1. So whatever our k is going to be our biggest amount here. So that means I've got negative infinity all the way through to k. So now we need to use our diagram from earlier to see what makes sense. So the first function that we're going to be looking at is going to be f g of x. So we get our g in, and then we're looking at our range of g is a subset of the domain. And this first part actually helps us out quite a bit. So I'm just going to underline the range of g. Oops. There's the pen. Okay, so straight away here, this needs to be the subset of the domain of f. So at the moment, for it to be a subset, we need to make k be 1. As soon as it's 1, equal to or greater than 1, it will be a subset. If we look at that other rule, which we've got g f of x, so it's the other way around, which also means that we're looking at f first, so range of f must be a subset of the domain of g. So let's look at that. It says the range of f, so I'm going to circle this time, range of f must be a subset of the domain of g. So the highest part for g is 2. That also means, oops, it also means that we know our k value. So our k value is to be greater or equal to 1, and it also has to be equal to or less than 2. Based on the information we have there.